Hello friends, welcome to Yashwantrao Chauhan Maharashtra Open University Nashik, School of Architecture, Science and Technology. Today we are going to discuss upon the program V92 BSc Physics Chemistry Mathematics course S41441 Mathematics 04, which is of groups and rings. Myself Tejasvi Kadam work as an academic coordinator in the School of Architecture, Science and Technology, Yashwantrao Chauhan Maharashtra Open University Nashik. So we will start with the credit 01, which is of groups. Unit 01.01 binary operation defined on a set. Now we will discuss upon the topic associative operation. Here we will read the operation name as dot instead of O. A binary operation dot on set A is said to be associative if A dot in bracket B dot C is equal to in round bracket A dot B bracket complete dot C for all A B C belongs to A. That is, while applying an operation on three elements, if we change the position of brackets, that is sequence of performance of the operation, and then also we get the same output, then that operation is called as a associative operation. Let us see one theorem. Addition and multiplication are associative on the set of real numbers. Suppose A, B, C are any real numbers, then A plus in bracket B plus C is equal to in bracket A plus B bracket complete plus C, that is equal to A plus B plus C. We know that while doing the addition of any three real numbers, sequence of performance of addition does not affect the output of addition. That's why addition is associative on the set of real numbers. Similarly, A dot in bracket B dot C is equal to in bracket A dot B dot C, that is equal to A dot B dot C. That is, multiplication is associative operation on the set of real numbers. Now we will consider one problem. Show that the subtraction is not associative on the set of real numbers. One counter example is enough to prove this claim. Consider 2, 3, 4 are the real numbers. 2 minus in the bracket 3 minus 4 is equal to 2 minus 1 is equal to 2 plus 1 is equal to 3. Now in the bracket 2 minus 3 minus 4 is equal to minus 1 minus 4 is equal to minus 5. Here we have performed the operation in the bracket first and then the next operation. So we have got 2 minus in the bracket 3 minus 4 is not equal to in the bracket 2 minus 3 minus 4. This shows that subtraction is not associative on the set of real numbers. Distributive operation. Let two binary operations denoted by dot and round plus be defined on a set A. The operation round plus is said to be distributive over the operation dot if A round plus in the bracket B dot C is equal to in the bracket A round plus B dot A round plus C. That is, here we are able to distribute the operation outside the bracket over the each element inside the bracket separately, and after that here we are applying the operation inside the bracket to these two brackets. Similarly, B dot C round plus A is equal to B round plus A dot C round plus A for all ABC belongs to A. Here we are distributing the operation outside the bracket over the operation inside the bracket. Similarly, the operation dot is distributive over the operation round plus if A dot in the bracket B round plus C is equal to A dot B round plus A dot C and B round plus C dot A is equal to B dot A round plus C dot A for all ABC belongs to A. See one theorem. On the set of real numbers, multiplication is distributive over addition. that is a into bracket b plus c is equal to a into b plus a into c. This holds for all real numbers. So multiplication is distributive over addition. Consider 2 into bracket 3 plus 7 is equal to 2 into 10. It is equal to 20. And 2 into 3 plus 2 into 7 is equal to 6 plus 14 is equal to 20. So here we are getting multiplication is distributive over addition. But addition is not distributive over multiplication on R. For that purpose, consider 2 plus in the bracket 3 into 7, which is equal to 2 plus 21 is equal to 23. And 2 plus 3 into 2 plus 7 is equal to 5 into 9. It is equal to 45. So we have got 2 plus in the bracket 3 into 7 is not equal to 2 plus 3 into 2 plus 7. That's why addition is not distributive over multiplication. One remark we will see. A binary operation on a set A is self-distributive if it is distributive over itself. That is, A dot in the bracket B dot C is equal to A dot B dot A dot C. For all ABC belongs to A. If an operation is distributive over itself, then it is called as a self-distributive operation. Now we will see the summary of the lecture. If G be a non-empty set, then dot is an associative operation on G if A dot in round bracket B dot C is equal to in round bracket A dot B bracket complete dot C for all ABC belongs to G. That is, while applying the same dot operation on three terms, order of performance of operation does not affect the output of the operation. Distributive operation. The operation round plus is said to be distributive over the operation dot if A round plus in the bracket B dot C is equal to in the bracket A round plus B bracket complete dot in the second bracket A round plus C. That is, here we are able to distribute the operation outside the bracket over the terms inside the bracket. Similarly, B dot C in the bracket round plus A is equal to in first bracket B round plus A dot in second bracket C round plus A. This must hold for all ABC belongs to G. If these both conditions hold, then operation round plus is said to be distributive over operation dot. In the next video, we will discuss upon the topics complex numbers and identity elements. Thank you.